Welcome to the laboratory session of Digital Design and Computer Organization, VTO code BCS302. This is Rasika Amrik, Assistant Professor, Computer Science, Cybersecurity, ATMEC, Mysuru. So today's experiment is experiment 2. Design a 4-bit full adder and subtractor and simulate the same using the basic gates. So the 4-bit binary addition of two numbers is comprises of. Before moving on to designing and simulating the 4-bit order logic circuit, first let us analyze what is the binary addition of two numbers comprises of. Binary addition always takes place with respect to zeros and ones only. So if I am considering A as 1010 binary bit number and B as 0111, the addition of these two numbers will be in the form 0 plus 1 will be 1. So here in the second bit addition, 1 plus 1 will take the sum as 0 and carry as 1. So as we know, the binary addition comprises of only zeros and ones. So when 1 plus 1 addition happens, it cannot be the decimal value 2 directly written as 2. It has to be represented in the 0 format only. So in order to represent that, the binary addition happens to be 1 plus 1 will be 0 forwarded with the carry 1. So again, when the carry is being provided to the third bit addition, so 1 plus 1, again it is 0 given with the carry 1. And here again in the fourth bit, the carried 1 will be added with this bit 1, so it becomes 0, and lastly the generated carry will be remained out. So this is the binary addition that takes place and the carry generated. Here we will design the circuit wherein the generated carry will be the output and the 4-bit adder comprises of the set of basic gates as represented in the picture. So we make use of electronic workbench in order to design this circuit. We have considered these 4 full adders connected with the indicators, one line of VCC and another line with respect to ground 0. VCC input value will always remain 1 and the ground value will always remain 0. There is one bit that is been given previously, that is C, as an input which remains 0, that is connected to ground. So here are the set of input lines that we develop in order to build this logical circuit. So P, Q, R, S are the set of values that are representing P as 0, Q as 1, R as 0, S as 1. So similarly in the same way, in this workbench the switches X, Y, W, X, Y, Z are represented by W as 1, Y as 1, X as 1 and Z as 0. So these are the switches that are connected with respect to ground and VCC. Whenever we need to provide the input as 0, the switches will be connected to ground, and whenever the input for this switch to be provided with 1, the input will be connected to VCC. So in the given example for the odd adder, the first set of bits considered as A are 0101. So in the electronic workbench, P is connected to 0, that is ground, Q is connected to VCC, R is connected to 0, S is connected to 1. So 0101. So likewise, if I go for the second set of bits, that is 1110, this is the LSB that we consider. So here W is connected to VCC, X is connected to VCC, Y is connected to VCC, and Z is connected to 0. So these are the initial inputs that are provided with respect to zeros and ones. The output obtained will be one carry generated. The next set of bits are 0 and the last is representing as 1. So this is the carry generated, the next set of bits, that is 0001. So it is providing the input. If I want to change the input values from 100, this as 0, then 1 plus 0 will remain 0. Sorry, it will be 1. 1 plus 1 is 0, and this will be the changes. So I have changed the 2-bit values here. Likewise, if I give P as 1 and W as 0, so you could see the output with respect to same. So with this, we conclude the experiment with the value carry generated 1 and the output as 1. The rest of the bits remains 0 with respect to the addition that is performed. Thank you.